Hi, I'm Cheryl, and I am the creator and inventor behind this little nanobot that I have named EASO. EASO is meant to serve as a long-term cure for patients with type 1 diabetes, and I will briefly just explain how this could possibly be used in the future. This nanobot is going to enter the human body through a blood vessel, preferably the femoral artery, which is in the thigh area because the artery itself is very big and it's also connected to the main circulatory system, so that when the nanobot enters the body through that area, it can easily move upstream and reach the pancreas or the liver. The nanobot itself is going to be powered by two motors. I have the motors here, one on this side and another on this side, right? And the motors is basically going to enable the nanobot to function and also to be able to travel and move with the help of two propellers. So these propellers are also known as shrouded propellers because they're covered so that the blades are not sticking out and poking the human body on the inside. The propellers is going to enable the nanobot to move with ease inside the human body. It'll move forward or backward accordingly. And then we will also have sensors on the nanobot. So on the top here, this area is going to be where we have the porous sensors. These sensors will basically sort of filter the blood and detect whether the patient's blood sugar levels are up or down, and if required, it will be able to automatically secrete the insulin that's required for the human body. So therefore, it's sort of simulating an artificial liver. And then we're going to have these insulin pumps here, these little pokey things. I have two of them, one here, and this insulin pump is going to be the area from where the insulin cells are emitted for the body. And the way the nanobot is going to know to do this is because there's going to be an embedded microchip on the inside where all the information and data are collected, and that will sort of indicate whether the human body at that point needs insulin or not. And then some other features as well. Yes, the bottom of the nanobot, we have what we call the anchor legs. So under Tinkercad, I used the chicken feet to make the anchors or the legs of the nanobot. It does stand up pretty well. Let me see. I can't quite show that to you right now, but it does. But it's a little unsteady too, so I figured that maybe I need to do either more legs or place them more strategically so that the nanobot itself is a lot more balanced. So this anchor here is going to help anchor the nanobot once it's inside the body, so that it's in the correct area of the body that requires insulin, and that in case there's a lot of movement inside the human body, it can stay still and continue its operation. So these little legs are supposed to help them do that, and it can be retractable, so it can come out when required, it can go back into the nanobot when it's not needed. And then because this nanobot is not going to remain inside the human body forever, patients will require 3 to 6 months of replacement, because the insulin pumps needs to be replaced if they run out of insulin eventually. So the nanobot will need a removal process. So once it's time for removal, the nanobot itself will travel to a blood vessel. It'll again anchor itself onto that blood vessel, and then using the microchip that's embedded, the doctors can track the location, and then a small surgical incision could be made, and then the nanobot could be retrieved from the human body and then reinserted whenever it's required again. So that's the basic function of the nanobot. I think it's pretty cool. I hope you did so too.